So let's say Akshay wants to understand when and how we are going to use four options from PV lead for nozzle design. So let's say when we are getting into the nozzle design options, we have to go into tools, set configuration, and nozzle analysis options. So here we can see there are four options. MAWP plus static head to the element bottom, design pressure plus static head, overall MAWP plus static head for governing element, and MAWP plus static head to the nozzle. When you want to design a nozzle, these four options are available. Usually, if you choose design pressure plus static head, so let's say the design pressure in this vessel is, let us have it as in MPa. Instead of that, we'll have it in bars Unicode so that we all can understand. This is, let's say, the shell. And the pressure is 10 bar. For simplicity of understanding, this is 0. And let's say this thickness is 14. So let us see what are the things which are going to get changed. So here 10 bar is the design pressure. We haven't filled any static head inside. So let's say the design pressure remains 10 bar only. So if you are choosing from this option tools, nozzle options, design pressure plus static head, and if we just look at the nozzle design calculations, you will see the pressure, what will be used in this calculation. So what is the pressure? 10 bar, what has been used in this calculation. So let's say I am adding two more element into this. So let's say I'm adding before elliptical head like this. And let's say there is one more cylindrical shell at the top. Here, the required thickness is how much? 12.2. Let's say I'm using 16 mm star point, 15% thinning I'm considering. So let's say the thickness is 16. Here the thickness is how much? 14. Here let's say I am providing the thickness as 12.5. And then we are doing the analysis and just going to check what is the MAWP of this entire vessel coming. So first of all, let us see whether the nozzle is passing. So the nozzle itself is failing, right, in area reinforcement calculations. So let's first add RF pad into this. This nozzle is failing in UG45. Let's say 160 schedule I am having. And I'm having a pad over here, right? So there is an ample area available over here. So what is the pressure at which the calculations have been done? We have chosen static head plus design pressure. So 10 bar is what considered over here. So let's perform the calculations and check what different MAWPs for the elements we are getting. And we are going to check one by one the MAWP options over there. So here we are going to see the MAWP 10.47 bar limited by the cylinder. You can see over here there are two shells. One is the bottom dish. Let us just redefine the names. This is the dish. This is shell number 1. This is shell number 2. And let us fill this with static head as well. Full. I am also going to fill this with static head. Full. And this will also be filled with static head of water, let's say. So now I am going to check at what pressure these calculations will be done and when to choose this option. Many times it happens that you must have seen in the specification that the nozzle reinforcement should not govern the MAWP of the vessel. So the weakest component must not be the nozzle or its reinforcement. That is what the specification requirement. Is this the code requirement? The answer is no. So here we can see 10.17 is shell course number 2, the top one. In between, whatever the shell is there on which the nozzle is present, that is having MAWP 11.55, and the dish is having MAWP of 11.13. So what option we have chosen? We have chosen the option MAWP plus static head? No, we have chosen the option design pressure plus static head. So for this nozzle, you can see what is the pressure? 10.448. Why so? Because the static head is 0.448 over here. The static pressure is how much? 0.448 till that particular nozzle. 10.448. So what pressure it has considered? The design pressure, which is 10 bar plus the static head, which is coming till that particular point. 10.448. Let us place this nozzle down below. You can see it over here. It is now increased, right? Because we have selected the nozzle at bottom. So the static head from this place to this place, the entire static head has been considered in the nozzle design. Is it clear, Akshay? So this is about when we are choosing design pressure plus static head. So let's say I have just given the RF pad just sufficient to pass this. So instead of this, I'm using 8 mm. This is 20. And I'm also decreasing this to 45. How much it is? 17. Let's say I'm putting it 40. Just about to pass whatever is required, I'm giving that 17. Let's say I'm putting it 30 over here. So it is just passing. So now I have given the RF pad requirement or the inputs, which is just sufficient to pass that, right? So let us see now when the calculations will be done. Here you can see MAWP is 10.03 and this is limited by the nozzle reinforcement. If you don't want the nozzle reinforcement to govern the MAWP, in that case, usually what we are doing, we are not choosing this option from the design. Here, what is the static head? 0.573. What is design pressure? 10. So the nozzle is designed for just 10.573 and we have just given the reinforcement pad dimension just to sufficiently take care of these requirements. Here you can see the area required is 7.4, 17.4 and available is 17.5. It is just passing into this. But if you don't want the nozzle to govern the MAWP, so that's the reason why the other options will come into the picture. So let's see the other option. Instead of this, MAWP plus static head to the nozzle. What was static head to the nozzle? 0.553, right? Plus MAWP. Now, let us see what is the pressure the nozzle is considering in the calculation. Now, it is 10.746. 10.746. From where it has come from? MAWP of the vessel, what has been considered. Let's say I'm running this. So now you can see the nozzle is failed in reinforcement because now it has been designed for, this is 10.17, right? 10.17 plus 0.5. So it becomes 10.77. That is what the pressure has been used over here. Static head plus design pressure. So here you can see MAWP of the vessel, which is 10.17 plus static head. This is what the pressure has been used in the calculation. And now it is failing. So what we usually do, we are going to increase this particular RF pad dimension. Let's say I'm going to put it 60. So now it is passing. So whether now this will govern the MAWP of the vessel? No. This will not govern the MAWP of the vessel. Now which option we have chosen? The second one. What does that tell us? We have designed it for MAWP of that entire vessel plus static head till the nozzle. If I shift the nozzle below, then these calculations will again change. If I move the nozzle at the top, these calculations will again change because the static head is changing. Now, there is third option. So if I shift this nozzle at the top, let's say I'm having it at 2500 or let's say 2000 elevation. So earlier we have seen 10.746 was the pressure considered. Now what is the pressure? 10.574. Why so? Because the nozzle is been shifted at the top. So till this point, whatever the static head is there, that has been considered. So during the calculation, many a times it happens that your nozzle elevation, because of the process requirement, piping requirement can change. What you are doing, you are going with the other option. So what is that other option? Or MAWP plus static head to the element bottom. So if you are choosing MAWP plus static head of the element bottom, so you can see in the calculation, it is 10.77, right? So it has considered the maximum static head. So even if I change its elevation, it is not going to get changed. It will remain the same. You are designing it for the worst case static head along with the MAWP of this particular vessel. So this is the most conservative option. Let's now look at this. So what is the pressure at which the calculations have been done? It's 10.77, right? Let us move this to the top. This is from 30 to 40. So I need to give it from node 30. This datum distance would be from the bottom, right? So let's say it is 4000. So now you can see the nozzle has been shifted at the top. Now, at what pressure it will be designed? So now it has taken the static head till this bottom. So if the nozzle is going to change its location only within that particular component, the worst case value will be chosen for that element. So let's say here, what is the pressure that has been considered? 10.471. So even if I change it to let's say 1200, it will remain the same 10.471 because it is considering the static head till this point. The element on which this nozzle is mounted, even if it is going to place anywhere on this particular element, its MAWP will not change or the design calculations will not change. But if we look at the other option, right? Overall MAWP plus static head of the governing element. Now look at. So what is the pressure at which we are designing it? 10.471. So let me just place this back to 20 and this is let's say 1000. 10.471 because MAWP plus static head of the governing element means the element which is governing the MAWP. We have seen that in the calculation of MAWP, there are three components. One is bottom dish, it is having MAWP 11.13. Then the in-between shell course number 1, it is having 11.55. And the third one, which is having 10.17. So what is the weakest component? 10.17, which is the topmost. And the static head at the bottom of this. So this is what the software is considering. If I increase this thickness to 16 mm, so what will happen? This is 14, this is 16. So now this becomes the weakest component. Now it assumes the MAWP of this component plus the static head at the bottom of that. So in nutshell, when we have to choose the first option from here, MAWP plus static head or this design pressure plus static head. Usually this is the option you are choosing when you have to optimize the vessel, and in which case even if the nozzle reinforcement is governing the vessel MAWP, you are okay with it. Is it the code requirement? No, that is the specification requirement. So for that case, you are choosing design pressure plus static head. When you are choosing MAWP plus static head to element bottom, so usually we are not choosing this option, MAWP plus static head of the element bottom. Let's say this nozzle is shifted from this to this. So it is considering till this option. If MAWP plus static head to the nozzle, MAWP plus the static head at the location where the nozzle is provided. So if the nozzle is changing, this calculation is going to get changed. And the worst case is what? Overall MAWP, whatever we have considered, plus static head of the governing element. But this may not be the worst case scenario. What would be the worst case scenario? MAWP plus static head to element bottom. If you choose this option, you will always get the nozzle designed for the highest pressure. And since you have designed it for the highest pressure, so it will not govern the MAWP. Is it clear? So usually we are going with which option? We are going with MAWP plus static head to the nozzle, the fourth one. So if the nozzle elevation changes, its static head changes and the calculation changes. But if you want to go with the worst case, then you can go with MAWP plus static head to the element bottom. Is it clear? And for the same, if you press F1, the same has been given in the help menu as well. So let us see that part also in detail. So here you can see these four options, right? So first, MAWP plus static head to the element bottom. Means if the nozzle is going to be on the same element and if it is going to move up and down, it will not change the calculation. The calculation will remain the same unless and until the nozzle will be shifted on the next element. So calculate the internal pressure on the nozzle on the bottom of the element where the nozzle is located. This pressure is the maximum allowable working pressure of the vessel plus the static head pressure to the bottom of that particular element. Thus, the design pressure can vary for the nozzle located on the different elements. Yes, of course. This option is appropriate if you are certain that the nozzle is not going to change its location on the other element. If you use this option and the nozzle is lowered in the vessel and under the additional pressure due to the liquid head, you must rerun the analysis. Then design pressure plus static head. The nozzle will be designed for actual design pressure plus wherever the nozzle is placed. So if the nozzle orientation elevation changes, then this thing will also change. And many times it happens that the nozzle reinforcement can govern the MAWP of the vessel. If you are not bothered by that, then you can choose with this option. Otherwise, you are not. Overall MAWP plus static head of the governing element. So here calculates the MAWP of the vessel and also consider the static pressure at the bottom of the element that is governing the MAWP. So what happens? The MAWP governing element could be at the bottom or could be at the top. So if the nozzle location on a vessel changes due to the client request, there is no need to rerun the nozzle calculation because the pressure used in this calculation does not change. Because here static head, you have not considered till the nozzle, you are considering till the governing element. So for every nozzle, the pressure will remain the same. MAWP of the vessel plus static head of the governing element, right? So for every nozzle, the pressure will remain the same. And usually we are going with this option. For every nozzle, the static head would be different. And if the nozzle changes, these calculations will also changes because we want the nozzle to be designed at the static head of that particular nozzle location. So let's say the 12 bar is MAWP and static head is another 1 bar. So the nozzle has to be designed for 13 bar. But in this case, it may happen the governing element could be at the top side. So it can add only 0.1 pressure. So the nozzles will be designed for 12 bar plus 0.1 for all the nozzles. But that may not add the static head till the nozzle location. So that is not the worst case, but we can say that this will be the standard pressure for which every nozzle will be designed for. So in nutshell, if you want to summarize, fourth option is what usually we are going ahead with. If you don't want the nozzle calculations to change, so you can go with this option. So for every nozzle, the design pressure will remain the same. For this, only design pressure plus static head will be considered. And here MAWP of the vessel plus the static head at the bottom of the element on which that particular the nozzle is placed, that will be considered. So on the same shell course, the nozzle if vary in up or down direction, even though the nozzle calculations will not change. But if it moves to the next element, then only calculations will change. So usually fourth option is what we are using in our calculations. So many a times this question has been asked. So I think this video I will make it available on our app as well, so that you all will be having always an access that which option among these four to be chosen. So is it clear, guys?